Welcome to the second video in Unit 2, Graphs and Function Notation. Here are the objectives for what we're going to do. I think I would also add to here we're going to continue to talk about transformations and their effect on parent graphs, but also function notation used to describe a transformation. Okay, here is a function. This is just some generic function. I put some specific points on here. We're going to have an exercise in class where I give you a function fairly similar to this and then ask you questions about it. So for instance, you can see that the domain of this function is not all reals because it actually ends from one to another. I haven't put any numbers on here, but it's fairly easy to count. So let's look at what I have here. I have number 1 says find f of 0, f of negative 2, and f of 4. Well, once again, this is function notation. So what it's saying is y equals f of x, right? So if I have y equals f of 0, what I'm looking for is where x is 0, what is the y? So f of 0, the y coordinate is 2. At f of negative 2, here's f of negative 2, this is the y coordinate that I want, 1, 2, 3, 4, 5. So f of negative 2 is 5. F of 4, 1, 2, 3, 4. If I look down here at this point, f of 4 is going to be 1, 2, 3, negative 3. So this is just notation that says at where x is 4, what is f of 4? What is y at that coordinate? Okay, number 2, what is the domain of this function? Well, when we look at domain, we're looking at all the possible x values. So I'm going to start over here, and this is going to include 1, 2, 3, 4, negative 5, all the way to 1, 2, 3, 4, 5, 6, but not including. So if I use interval notation, it would go from negative 5 to 6, but not include 6. Number 3 says, what are the intercepts? Okay, what are the intercepts? Well, am I talking about just x-intercepts? No. I'm going to have x-intercepts and a y-intercept. And if it's a function, it will only have one y-intercept. The y-intercept is at 0, 2, and the x-intercepts are where it crosses the x-axis. There are 3 of them. And if I list them as points, I have 1, 2, 3, negative 4, 0. I have 2, 0. And I have 3, 4, 5, 0. Okay, and this had the question mark cut off of it. But number 4 says, for what values of x is f of x equal to 2? Well, guys, the easiest way I know how to do this is to draw a line through here. And this is a terrible graph, and I apologize. But there are 3 places where that is equal to 2. And it's hard to tell, right? So it's probably somewhere here, at 0, 2, and here. Another way you could say that is if f of where is f of x equal to 2? Let's say it that way. Where is f of x equal to, 0? And once again, that's just another way of saying where are the x-intercepts? F of x equals 0. So in other words, we're saying where are all the points where the y coordinate is known. I could also have said this one. F of x equals negative 3. And there are 2 points for which that is true. So there are lots of other questions that we can ask about this graph, but here are 4. This will get you started, and then we'll do some more in class on this. So I want to talk again about describing the translation. And remember that our goal is to be able to graph parent functions with the translations without having to plot points or put it in a calculator. So here we are. This is just a recap of what we've done in class. the parent function for this is y equals the absolute value of x. So this is the absolute value of x. We know that the absolute value of x looks like it has a point at 0, 0, over 1, up 1, and it is a V shape. That's what its basic graph looks like. So if I have this function right here, if I say the absolute value of x plus 2, then what I'm doing is I am moving this up, this function up 2. So with the plus 2 on the outside, that will move the entire graph up 2 units. So a minus here, guess what that does? This moves it down 2 units. So if on the outside of the absolute value it moves it up and down, inside the absolute value is going to move it left or right. If it's plus on the inside, it moves it left 2 units. If it's minus on the inside, it moves it right 2 units. So this one here and this one here this one has 1, this has both. Okay, so this is going to move it to the right 4 units. This is going to move it right 2 units and up 2 units. So this, remember that the parent function y equals the absolute value of x has its point at 0, 0, over 1, up 1, over 1, up 1. And this negative out in front is going to change its direction. So instead of up 1, it's going to look like this, the blue. So we call this a reflection in the x-axis. Okay? Now, y equals x squared is a quadratic. It's centered at 0, 0, over 1, up 1, over 2, up 4. So it looks curvy, like this. All right. So a negative is going to turn it upside down, just like this, a reflection in the x-axis. So here's an equation. Like I said, once again, we're heading towards the ability to graph it without having to plot points. So here we have your basic parent graph, and we have over 1, up 1, over 1, up 1. So this is the absolute value of x. Now, when we add this to it, notice that this number out front, not the minus, but the number out front, the 1/4, is a shrink. Notice it's getting closer to the x-axis. The negative flips it over, right? This is right side up, this is flipped over. This moves it to the left, right? A plus on the inside moves it to the left, and a negative on the outside moves it down. So we can see that it moves it down. We can see that it moves it left. Okay, so this is what this translates into, right? So we have plus 4 translates f of x right 2 units. Nope, that's not true. That's left. Negative 2 translates it down. Yes. Negative 1/4 translates it across the x-axis. No, just the minus does that. And D moves this right. No, this is a shrink. So the answer, the correct answer for this is B. But I want you to begin to see how these pieces translate into a graph. So here's a concept summary, what we talk about here when we're writing it. So if we say inside, in the parent function, for no matter what parent function it is, if we add a value inside, we're moving things left. If we put a minus inside the function, and for instance, what I'm saying here is if the parent function is x squared, right? To move it left, I would say y equals x plus 2. That would move it left. Y equals x minus 2 would move it right. To move it up, I would say x equals x squared plus 1. And moving it down, y equals x squared minus 1. If I said y equals negative x squared, it's going to translate it in the x-axis. Means it's going to flip it upside down like this. And if I do this, it will translate it around the y-axis. And actually it already is, so that's why that looks kind of funny. Dilations are stretch or shrink. So this one would be like, say if a is bigger than 1, say I say 6x squared, it's going to make it really skinny. Compressing or shrink, if I said 1/6, it's going to make it wider, like that. And then these last two, we'll talk more about these in class, but that's going to actually compress it horizontally and shrink it and stretch it horizontally. And we see that a lot in trig functions and not as much in these parent functions, so I'm not going to highlight it as much, but I do want you to be familiar with the translations, reflections, and the basic stretch and shrink. So in class, we're going to work some more with this, and I promise we're going to get really good at it. All right, see you in class.